Okay.
Okay, please.
Okay,
lead it.
let's go.
Let's go. One of our first item on the dynamic measurement testing.
For motorized spindles.
Yes, temperature saturation process, aka run-in.
Run-in test.
Yes, run-in test. So here we monitor and record the temperature rising stability from 0 to its maximum high speed, RPM.
Okay. So
by adding 1000 RPM each time until we reach its highest rotation speed, highest RPM.
Incremental steps, and at each step you will measure the temperature.
Absolutely, yes.
Okay.
As you see here, it's the temperature degrees. The maximum is 60.
Okay.
And here is the line, it's a timeline. And there is the revolution per minute,
so the
RPM, spindle speed, till we reach its maximum.
Yep, got it.
Yep. And under normal circumstances, won't exceed 30 degrees.
Okay, okay, so that's the goal.
That's yeah, of course. And we have to record every step all the way.
All the way. All right, so that was the run-in test, but that's only one of 4 items, I believe, on the dynamic measurement list, right?
Yes,
so
exactly,
what's up next? What else do we have?
The second thing I see here is the frequency measurement.
Frequency?
Yes, the frequency analysis is to measure the spindle operation. So we'll make sure that the spindle rotation is perfectly good.
Okay.
As you see on the screen, when it's first, second, third order are gradually decreasing, that means the spindles are perfectly good.
Okay, perfect soul power quality.
Absolutely, yes.
Okay, beautiful. Now also another important topic, we want to talk about vibration. You want to keep it low,
of course,
because it's very important for the accuracy.
It's one of the main advantages of the spindle, actually, to have a low vibration. So on our measurement here at Soul Power, our vibration measurement are based on ISO 17243.
All right.
So
again, international standard.
Absolutely, yes. It's the highest international standards for the vibration.
Yeah.
The rotation speed here starts from 600 RPM till 30,000 RPM.
Oh, wow, all the way up to 30,000 RPM.
And it's also suitable for roller bearing and ball bearing as well.
Okay, excellent. So vibration testing. Now we have one more item on the list when it comes to dynamic measurements.
Balancing, I believe.
Balancing. So we want to keep the spindle well balanced.
Of course, yes. It's to integrate the central line of mass with rotational axis.
Okay.
Yeah, so we'll have a high accuracy and a better surface finish and a higher removal rate and to increase, of course, the tooling life as well.
Okay, so 4 things you just mentioned. I'm sure people who are looking for a motorized spindle, they will very much care about,
yes,
right?
it's one of the main advantages of the motorized spindle itself.
Okay.
Yes, to be very high accurate, high precision.
Okay, and again, I think here you also testing according to ISO standards, right?
Yes. Our balancing inspection here at Soul Power is based on ISO 1940.
Okay, so again, meeting international standards?
Yes, absolutely, yes.
Okay, okay.
Actually, the mechanism behind the motorized spindle, as you already know and our audience know, it's very complicated.
It is indeed.
So, most of our dynamic measurement has to be done twice.
Okay.
So, we have to make sure there's no space or place for error here.
Okay, so meeting 100% quality.
Absolutely, 110%.
110%.
Yes,
okay,
110,
excellent. So that was the balancing, the last item on our dynamic measurement list.
Yes.
But now we want to move on to the static measurements.
Yes.
And I believe we have to go
to another area. Yes.
Okay, you want to take me there now?
Yes, please. Yes,
okay,
let's go.
All right, Sam, so we just covered dynamic measurements and now we want to talk about static measurements, right?
Of course, yes. We're going to start talking about static measurement first, then clamping force, then we'll end up with, eventually, with the run out.
Run out, okay.
Yes.
Okay, so static measurements, what do we need to know about?
Well, at Soul Power here we have to focus on 2 points, 2 things. The axial rigidity and the radial rigidity.
Okay, axial and radial rigidity.
Yes, these are very important.
Right. Obviously, rigidity is very important, right?
Because it have to do a lot with the quality of the workpiece you're working on. So those inspections, the axial and the radial has to pass our measurement.
Okay.
Yes, in order to ensure our customer that he can get the quality he required.
Yeah, that's the main target, that's the main goal.
Of course, yes.
Okay, so what else do we have?
We have the clamping force.
Okay.
Besides testing the clamping force, we need to test the draw bar endorsement.
Okay.
Besides the draw bar, we have the axial thermal growth of the shaft.
Thermal growth of the shaft. Okay.
Yes, the axial.
Very technical,
Of course, yes, because we have to ensure the quality of our motorized spindle, our built-in spindle, in order to get to the best quality we can achieve, we can get.
Okay, wow, I mean, we just talked about the dynamic measurements, then now the static measurements and additional tests, additional inspections. So altogether, I think like 10, 11, 12 different inspection procedures for your motorized spindle.
Well, I stopped counting one time ago.
Yeah, well, I mean, I don't know how many, but it's quite a lot, and I think there's even more that you want to talk about,
the mechanism behind that is very, very wide.
And another thing that I think that you mentioned earlier is the runouts.
I think there's the runout cell, yes.
Yeah?
Okay, finally, we're going to be talking about the runout.
Okay.
There are 4 positions to measure before shipping out the spindle itself.
All right.
The taper, inside the taper, we have to measure the accuracy. It should be, and actually it must be, less or equal to 0.002 millimeter.
Okay.
And the second position, it's the taper face itself, outside. We have to measure it, the same thing.
And the tolerance there?
0.002 millimeters.
Okay, same.
So the third position we have to test is the root of the test bar, which has to be equal to 0.003. Then the fourth part, we have to test the test bar itself, run out, which has to be equal to 0.008.
All right.
Yes.
Okay, so that was that inspection.
The run out.
The run out inspection, right?
Yes.
Okay, so thank you, Sam, for showing us dynamic measurements, static measurements, and all the other inspections. But there's even more. But there are some inspection procedures that you couldn't or wouldn't show us, right?
Well, yes, it's a policy. There's some customized machine. Yeah, made for solar power. So.
Okay. Not meant for the public.
Absolutely, yes.
Okay, beautiful. Yep. So I think we're done here, but I know that you want to share even more with us today about your capabilities when it comes to the manufacture of motorized spindles, right?
Absolutely. What about we go back to where we started?